Hi to everyone, this is your Shankarappa sir. In today's video, we will discuss about microwave devices and their measurements of the different parameters. By using the microwave bench setup, we can measure the different parameters like scattering matrix of the magic can be determined, VSWR can be measured, VSWR measurements can be done, attenuation measurements can be done, frequency and wavelength can be measured, and also direction coupler characteristics can also be determined, and some more parameters like gun diode characteristics, the reflex klystron characteristics are also to be measured by using the microwave bench setup. Now we can see what are all the components it may have and how they are to be operated at different levels of the frequencies. Okay, it is a used microwave bench setup to measure the different components which are to be done in the laboratory. Now we can see the different components of this microwave bench setup. First, this is the microwave source. So here the source is the klystron power supply. Source is the klystron power supply. And next, this will be the klystron mount. So it is the klystron mount. So this one is the klystron mount. And next one is it is isolator. And this one is the variable attenuator. And this is the frequency meter. This one is the frequency meter. And this will be the slotted section, slotted section. And this will be connected with the detector mount. So it is the detector mount. That probe will be connected to the detecting meter, either to the CRO or to the VSWR meter. So it is the used bench setup to measure the different components of the microwave, or the different experiments are to be done by using this microwave bench setup. Now, it is the microwave source. It is a klystron power supply and a klystron mount. These two are called as the microwave source. When the experiment is ready to conduct, the first step while doing the experiment is switch on the fan. So it is the fan. This can be switched on. Later, the microwave source, that is klystron power supply source, is to be switched on. Klystron power supply is to be switched on. So if you observe, this klystron power supply has a meter select. So it has the meter select. It has the three terminals, V, C, R, E, P. V will be the representation of the voltage and the current, and this one is the repeller voltage. And this has beam voltage and repeller voltage. Initially, this to be kept at the voltage level, and HT is to be on. By keeping this at voltage level, you adjust this beam voltage to get the 230 volts in the meter. So get to adjust this to the 230 volts. So it is 230 volts. Now after 230, you turn this terminal towards the current. So initially you have to note down that 230 volts. The beam current is also to be noted. Initially the beam voltage is 230 volts. Later the beam current is 15 milliamps. Then this to be moved to the repeller. Now by adjusting this repeller, we have to observe the perfect square wave in the CRO. Perfect square wave in the CRO. If there is a perfect square wave in the CRO, then we can say that it is to be under the perfect condition. Bench is to be operating under the perfect condition. If there is no proper signal, then we will not receive any perfect square wave in the CRO. Until to get the CRO as a perfect square wave, the bench is not to be under proper condition. Once we get the perfect square wave in the CRO, then we can assume that we can say that the bench is to be under the proper condition. It is under the proper condition. Bench is to be operated under the proper condition. Now, for any experiment, we have to get these primary instructions. First one is the beam voltage. It has to be kept at 230 volts. It has to be kept at 230 volts. Later, the beam current is to be noted. Later, it is to be moved to the repeller voltage. The repeller voltage is to be noted by noting that get the perfect square wave in the CR. Get the perfect square wave in the CR. So it is the bench setting. Now, by using this, we can do any experiment which are to be connected by this microwave bench setting. So let me see the direction coupler measurement. So it is the direction coupler. It is the direction coupler. This one is the direction coupler. It is a 4-port junction device. 4-port junction device. It is a port 1 and this one is a port 2. It is port 3. When it is to be reversed, when it is to be connected reverse, then it will act as the port 4. So theoretically, we can say that this direction coupler is a 4-port junction device. The 4th port is permanently blocked. While measuring the different powers by using this, we can have the incident power, reflected power, back power and the forward power. The back power of this direction coupler is almost 0. Theoretically it is 0. While measuring the back power by using the microwave bench setup, it is to be turned towards to the opposite direction. That power is to be noted as P4. Okay. So let me see. So I already told you what all the instructions are to be followed to do the experiment by using the microwave bench setup. So I have to keep this repeller voltage to be at 230 volts. That current is to be noted. 230 volts.
Beam voltage 230.
That current is to be noted. Then it has to turn to the current, that is beam current, that 16 milliamps as per this reading. It is 16 milliamps is to be noted. Later is to be turned to the repeller, that also to be noted. And then we can observe the square wave in the CRO. And particularly there is a different modes existing in this reflex klystron or the klystron power supply. One is the continuous wave, AM wave, FM wave and extension mode. Generally, while doing this experiment, the klystron power supply is to be operated at AM mode, amplitude mode. By using this AM, we can get the frequency and the amplitude. When the frequency and amplitude are to be adjusted, we can get the variation in the CR. In the amplitude and also the time period. Frequency and time period can be varied. Now, my friend is varying that amplitude and frequency. You can see that how it is to be varying. When the frequency and amplitudes are to be varying, so it is a variant of frequency. Now, this is the adjustment of the amplitude. By adjusting the amplitude and the frequency, we can vary the signal variation. Okay. Now, while doing this experiment, these are the first initial instructions. Now, let me start the direction coupler experiment. After getting this perfect square wave in the CRO, this probe is to be connected to the VSWR meter. So it is the VSWR meter. And this has the different ranges: 0 decibels, 10 decibels, 20 decibels, 30 decibels, etc., 60 decibels. If there is an overrange, that means that reading is to be existing out of the range. So that is to be turned towards to the existing range. So it is the existing range. So it's now it is to be at 20 decibels. It is 20.
1.5.
This shows that 1.40 or 50. That means 20 plus 1.40, 21.50 decibels of the power in the VSWR meter. Now, while doing this direction coupler experiment, bench is to be under the proper condition. Initially, this detector mount is directly connected to this slotted section. That will be connected to the VSWR meter. That reading is to be noted as P1. That reading will be equal to 21.5 decibels. 21.50 decibels. Later, this detector mount is to be removed. This is to be removed. While removing this, it may take some time. So while doing this experiment, this HT is there, that is to be switched off. Now the direction coupler is connected. Now, in order to find the value of power at port 2, this is the second port 2. This to be connected to the detector. This will be connected to the detector, and port 3 is to be terminated. Anyhow, this fourth port is permanently blocked. This port 2 is to be connected to the detector mount, and this reading is to be identified by using this VSWR meter. So in the VSWR meter, it indicates that 27.8, it's around 28 decibels. So it is the P2. So initially we are calculated P1, now we are calculating P2 as 28 or 27.8 decibels. Okay. Similarly, we can find the value of P3 and P4. So in order to connect the third port, the second port is to be black. This third port is to be connected with the detector mount. And this second port is to be terminated by this terminating block. While detecting the third port power P3, HT is to be on. So it is HT is to be on, and the corresponding reading in the detector mount, which is to be connected to the VSWR meter, is to be noted. So this VSWR meter reading is to be noted. So it's around 32.2 decibels. So it is P3. So after completing the P3, he switch off that HT. HT is to be switched off to avoid the Klystron power supply getting heated. The radiation can be avoided. To find the value of P4, just you reverse this direction coupler. So it is to be connected in the reverse order. So here initially it is P1, it is port 1, this is port 1, this one is port 2, this is port 3. After getting back, after reversing, now this becomes to be the P4. That P4 will be the back power. In order to find the value of back power, this other port is to be terminated. The empty port is to be terminated. This is to be terminated. Now this is to be connected to the detector mount. To find the value of P4 in the VSWR meter is switch on this HT. HT is to be switched on. You observe the reading in the VSWR meter. So it's around 40, it is 40 plus 1, 41 decibels. So it is to be 41 decibels. After finding the value of P4, you switch off this HT. We are calculated P1, P2, P3 and P4. By using these powers, we can find the different parameters: coupling factor, directivity, isolation and insertion loss. By using the formulas of coupling factor C equal to P1 minus P3, that will be evaluated in terms of the decibels. Directivity D equal to P3 minus P4, that is also in terms of the decibels. Insertion loss notated by capital L, it is to be measured by using the formula of P1 minus P2, and isolation is notated by I, it is to be expressed by using the formula of P1 minus P4. By noting down all the readings of P1 to P4, we can find these parameters in the directional coupler experiment. Okay, so it's about directional coupler experiment. I think everybody can understand the concept of direction coupler in the microwave laboratory. Thank you all for referring my video and seeing my video. I am requesting you all subscribe, share and like my videos. Thank you all.